In the last example, we saw this case where the chemical energy in the battery was going down, and at the same time, the gravitational potential energy of the weight is going up. Remember, gravitational potential energy is the energy of something that's high up, so as the weight is raised, we're reducing the chemical energy in the battery, and we're raising the potential energy of the weight. In the 1800s, scientists were doing a lot of experiments very similar to this to try to figure out the relationship between the amount of energy that goes down and the amount of energy that goes up for different machines and devices that they were inventing. And they didn't know it at the time, but the idea that they came up with now, after 150 or 200 years, you could even say that this is the most important idea in the universe. So what is this big idea? Well, it has two parts. The first statement is that all energy must come from somewhere. And the second statement is that all energy must go somewhere. So energy must always come from somewhere, energy must always go somewhere. That means there's some things that are not allowed for energy. So not allowed, you can never, let's do it like this, you can never create energy, and you can never use up energy. Because you can't create energy, it had to come from somewhere. You can't use it up altogether because it can't be used up, it can only go somewhere. And in some ways, these ideas go against what we're used to talking about when we talk about energy, because we might say that when you use phone all day, the energy in the battery is going down and we've used up the energy in the battery. Or if you're burning a fire, you're burning some wood to make a fire, and eventually the fire goes out, we might say that we've used up the energy of that wood. But what we'll see is that it's not really accurate to say that the energy is used up, and we can understand the universe much better if we think like an energy detective and we ask ourselves, where did that energy go? In order to understand this more clearly, I think it's helpful to start with an analogy to money. So what I'm going to do here is draw out a wallet, and let's put some money in that wallet. We'll give you $5. So there's 1, 2, 3, 4, 5. $5. So you have $5 at the start. And let's just draw out each one of these dollar bills. So here's one. Oops. Here's 2. Here's 3, 4, and 5. Okay, and so we could label this as this is all the money in your wallet. And we'll just draw a box around that. Okay, so if you start the day with $5 in your wallet, and let's say around lunchtime you get a little hungry, so you go out and you spend $2 to buy some pizza. Then maybe in the afternoon, you decide you're going to spend $1 to buy a soda. First of all, these aren't very good fuel choices for your body, but that's not really our point here. But so then you could ask, well, how much money do we have at the end of the day? We started with 5. Sure looks like now we have 1, 2. So maybe we would say that we have $2 at the end of the day. Well, I'm going to show you that it's not really accurate to say that those $3 that we've spent have been used up or disappeared. It's just that they aren't in our wallet anymore, but all $5 are still there. Because if we just expand this box to think not only about the money that we have, but about also the store, then it's pretty easy to see that every dollar that you spent that's less in your wallet is going to be $1 more that the store has. So let's draw those $3 right here. And so now, if we ask the question of, there were $5 at the start of the day, how many of those dollars are still there at the end of the day? It's easy to see that the answer is 1, 2, 3, 4, 5. So instead of saying that we only have $2 at the end of the day, it's more accurate to say there are still $5 at the end of the day. Now, you don't have all of those dollars. They aren't necessarily all useful for you, but the point is that just like all energy must go somewhere, all money, when it's used up, must go somewhere. And in fact, this is true not just like on a one-day basis or on a one-person basis, but if you were to go and count all the money in the entire world, you count dollars and euros and the gold buried by pirates long ago, if you count all of them in the world today, then everyone go about their business for a week. Some people will get richer, some people will get poorer, some people will sell things, some people will buy things. And then you count the money at the end of the week, you would expect that the amount of money at the beginning of the week and the end of the week should be exactly the same. And it works the same way with energy. When you set up a machine, the energy that exists at the beginning and the energy that exists at the end will be the same. It's just that it might not all be in the place it started at the beginning or the form that it did at the beginning. And so like an energy detective, we need to look, that energy that we thought got used up, where did it go? So let's use that example that we had up above. So here's a battery hooked up to a motor that's lifting a weight. So there's our rope, and I'll put that weight way down here to start. And just need to connect the battery with some wires. There you go. Now it can run. Well, at the beginning, this battery might have a full charge. So it has all this chemical energy. And at the end, after we've lifted the weight, then the battery is going to have an empty charge. So after, we could say that the battery has less energy. We've talked about this already. And we'll also say that the weight has more energy because now it's higher up. And the key idea that comes from this most important idea in the universe is that every bit of energy every bit that the energy in the battery has gone down, we need to be able to find that energy somewhere else. So either the weight has more energy, or maybe the motor heated up a little, so that's some thermal energy. But the point is that if we count all the energy in the battery at the beginning, and then afterwards we count all the energy in the battery, the motor, the weight, everything at the end, we need to have the same amount as what we started with. Just like how when you spend those $3, they aren't really used up, they're just somewhere else. So what we're going to see in the next few videos is some examples of thinking like an energy detective and understanding when it looks like energy is disappearing, how can we really see where did it go? Because all energy must go somewhere.